In this video, I want to give you one of many reasons why we might prefer to use radians rather than degrees. And I want to look at how we calculate arc length. So if we were working in degrees, we know we would take the fraction of the circle. So we know the sum of the angles in the circle is 360. So we would take the angle theta, which is here, divided by 360, which is the fraction of the circle, and then we would multiply it by the circumference of the whole circle, which we know is 2 pi r. And if we simplify that, we can end up with a formula of theta pi r over 180, which will calculate the length of the red arc. However, let's do this same thing in radians. So if we have an angle of theta radians, we know that the sum of the angles around the point in radians is 2 pi. So the fraction of the circumference that we're looking for is theta over 2 pi. And let's multiply that by the circumference of the circle, which is 2 pi r. And notice this simplifies, and we end up with the formula theta r. So that is a really nice formula for the length of an arc. So the arc length is equal to theta times r, where theta is in radians. And let's just try and use this formula in an example. So in this example here on the left, we have the radius is 8, and we have in radians an angle of pi over 2. So if we wanted to calculate the arc length, so the red length, we know the arc length is equal to theta times r, which is pi over 2 times 8, which is just 4 pi, and I haven't given any units here, so 4 pi units. Let's consider a sector of a circle here, where we have a radius of r and an angle of 1 radian. Let's think about how long the arc length is when we have an angle of 1 radian. So the arc length is equal to theta times r, but we know that theta equals 1 radian. So we know that the arc length is equal to r. Well, let's think about what that is telling us. That is telling us that we have a radius that is equal to the arc length. And whenever we have a radius that is equal to the arc length, the angle is 1 radian. So this is a good way of thinking about what 1 radian actually is the angle that gives us a sector of a circle where the radius and the arc length are equal. So if we take something like this, and we know that this length and this length is equal, but also this length here is equal, then we know that this angle here is 1 radian. And that's a really nice way of thinking what a radian is. And it's actually much more useful than thinking in degrees.